The bundle is made by R-Tools Technology and DeepSpar, two Canadian companies who have each been developing professional data recovery tools for more than 20 years. It includes the USB stabilizer tech hardware device and a license of RStudio Technician software. There are three types of problems that can prevent access to data: logical corruption, hardware read instabilities, and total device failure. The most common type of problem is logical corruption, when the storage device is still physically healthy, but something happened on the software level, like accidental file deletion, accidental reformatting, damage from malware, or various operating system bugs. File system metadata is a bit like the table of contents of a book. It holds the file and folder names as well as the exact addresses where every file is stored. When a file is deleted, only its file system entry gets adjusted to mark its space as available for future use. Until this space gets overwritten with new data, the file remains on the drive and can be easily recovered by RStudio. In more serious forms of logical corruption, file system metadata can be entirely lost. For example, when a partition is accidentally reformatted, the entire file system can get overwritten. As new data is written to this new partition, some of the old data gets overwritten and permanently lost. The level of recoverability in this case will depend on the type of storage device this is, how quickly data recovery can be attempted, and how much data has been written to this new partition. The only way to find files in this case is by scanning the entire drive to do raw recovery. RStudio is a powerful engine which can automatically carve out files and sort them by their type without relying on file system metadata. This process allows recovering files even from drives with heavily corrupted or missing file systems. However, such recoveries are often partial and the original file and folder names will usually be lost, because they are a part of file system metadata. RStudio makes an educated guess about the condition of each recovered file, and files can be easily opened to confirm their integrity, even before they are saved. RStudio can also handle common types of encryption, like File Vault, which is widely used by Macs. If a drive is encrypted by File Vault, then retrieving the files will require the password, but otherwise the process is the same. RStudio also supports most types of RAID arrays. If the RAID array is simple, for example, a 2-drive RAID 0, then it will usually be automatically reassembled by RStudio, and no additional steps are required to recover the data. If the RAID array is complex, for example a 4-drive RAID 5, then it may require manual configuration and knowledge of file system structures, but the data can still be recovered. The second most common type of problem is read instability. Unstable devices still identify in BIOS, but have bad sectors or other problems which cause them to work slowly or intermittently. RStudio and USB Stabilizer include a series of features which make the recovery process faster and, more importantly, safer, resulting in improved data recovery from degraded drives. USB Stabilizer is a combination of a hardware device and kernel driver, which stabilize the USB connection to prevent the drive from being dropped by Windows, enforce read timeout by hardware reset or repower to speed up error handling and make it less damaging to the drive, block all writes, prevent Windows and other applications from accessing the connected drive, and provide protection from short circuits and electrostatic shock. Software-only data recovery applications do not have direct control of or exclusive access to the drive. They can only send read commands to the OS API. When dealing with healthy drives, data passes back and forth through each layer of the system software without any issues. However, none of these layers are designed to deal with degraded drives. So if the drive responds with errors or simply doesn't respond quickly enough, then any layer of system software could suffer an exception. This can cause many different behaviors. For example, the computer could hang, the drive could suddenly be dropped, file copying could take an exceptionally long time, or it could fail due to an error. The drive could also be very slow to mount, while Windows attempts to read and repair any corrupt file system elements it comes across, which in many cases will cause it to simply erase the elements that it can't understand, causing permanent data loss without even notifying the user that anything went wrong. USB Stabilizer blocks Windows from working with the storage device, so it doesn't have a chance to overwrite anything, and our system doesn't hang. All Windows can see is an unknown storage device which it cannot access. USB Stabilizer hardware contains an ARM processor, which separately maintains two USB connections, one to the PC and one to the source drive. RStudio sends requests to the USB Stabilizer, which then communicates with the source drive in a separate instance. If the connection with the source drive is interrupted for any reason, it is automatically re-established and Windows remains unaware of any issues, ensuring that RStudio has control over the drive and that instabilities do not cause our computer to crash, hang, or drop the drive. Our recovery does not abort even if we suddenly disconnect the drive, as USB stabilizer hardware continues to maintain the connection. Another advantage provided by USB stabilizer is hardware error handling. Storage devices can suffer a number of non-critical exceptions during recovery, with the most common being I/O errors or bad sectors. Bad sectors can be caused by a wide range of issues, including electronic instabilities and firmware corruption. But by far the most common cause is physical degradation of the drive's heads or platters. Every time the drive hits bad sector, it spends anywhere from a few seconds to over a minute making hundreds of internal read retries, then writes to the service area on its platters to update various logs, and finally responds with an error. This process wastes time, quickly causes further physical degradation of the drive, and risks firmware corruption. USB stabilizer uses hardware resets to force the drive to abort failed reads, reducing the number of internal read retries, and in most cases stopping the drive from recording the error in its service area. This functionality makes the recovery process much safer, reducing the chance of total drive failure during the recovery process. It can be easy to hear how much less the drive has to struggle when hardware resets are being used. It also makes drives behave in a more predictable manner by reducing long-term hanging, which allows recovering more heavily degraded drives. Solid-state drives have a lot of the same read instability issues as hard drives. Flash memory can also degrade, causing bad sectors to appear, and there are similar benefits from hardware error handling. For example, here we have NVMe SSD, which only reads for a few seconds before hanging the PC. We begin by connecting this drive to USB stabilizer through an adapter. The source USB port starts off unpowered, which makes it safer to plug in the drive. Leaving the drive powered off until the recovery is ready to be started is also beneficial, as it prevents the drive from initiating harmful self-scan procedures. The source USB port also has protection from short circuits and electrostatic shock. Even if there's a short circuit in the middle of the recovery, power will automatically cut off, in most cases preventing the drive from suffering further damage. We begin by configuring the read instability handling process for SSDs. Then we power on the drive and proceed with the recovery. USB stabilizer automatically repowers the SSD whenever it hangs, allowing us to continue. Another useful feature provided by RStudio is multi-pass imaging. For example, if we start imaging a degraded drive using traditional linear imaging, we may run into a platter scratch at the beginning of the drive, which quickly stops our imaging process. With multi-pass imaging, this platter scratch is quickly skipped, so we can move on. The damaged area will be attempted only during later phases after all healthy areas have been recovered, allowing us to get at least a partial image from the drive. RStudio also provides a specialized mode of operation called runtime imaging. In this mode, every sector being read is backed up to an image file in real time. A sector map is also maintained, which lets us know exactly which sectors have already been recovered in the past. For example, if we open a partition on a degraded drive, it takes a few minutes because the drive is slow to respond. If we do it again, it only takes a few seconds because the sector map let us know that we already recovered this data in the past. So we automatically read it from the healthy image instead of reading the degraded source drive again. This mode also allows us to make the file imaging process much more efficient. Traditional file recovery methods work by recovering one file at a time, meaning that every sector of the first file is recovered before moving on to the next file. Because files are often fragmented, this requires much more movement from the read-write heads, which slows down the recovery speed and applies additional stress on the drive. Instead of doing that, RStudio builds an internal map of all the sectors that belong to marked files, and then reads those sectors sequentially, which is faster and safer. We can also choose to skip files with bad sectors so that we stop reading a file and deselect all of its future fragments as soon as a single bad sector is found. This mode is particularly helpful when recovering pictures like JPEGs because they will usually fail to open due to a single bad sector. So continuing to recover them after that point just wastes time and causes unnecessary harm to the drive. The sector map also allows us to see which files are affected by bad sectors and we can create an HTML file report to easily communicate this information. This report is particularly useful for data recovery service providers to create transparency so that the customer can see the real result of the recovery prior to paying for it. This can help prevent them from being surprised that some corrupt files do not open, thereby reducing the number of refund requests. The third type of problem that storage devices can experience is total failure. These drives will not identify in BIOS and will often make clicking noises. These cases cannot be handled by our solution as most of them will require physical repairs in a Class 100 Clean Air workstation. The functionality shown in this video was previously only available in multi-thousand-dollar data recovery hardware. By partnering together, DeepSpar and our tools work to dramatically decrease the cost, opening up opportunities for more companies to perform effective in-house data recovery. Thank you for watching.